Today we will continue to solve the problem 2.27 of Griffith third edition Introduction to Quantum Mechanics. This is part 2. In previous class we have seen the relation that e power 2ka minus 1 is equal to e power 2ka plus 1 multiplied by 2m alpha over h cross squared k minus 1. Now what we are going to do is you multiply this exponential term with the second term in the bracket. Then you will get e power 2ka multiplied by this 2m alpha over h cross squared k minus 1. Then you multiply this by 1. Then you will get the terms inside the bracket. That is 2m alpha over h cross squared minus 1. Now what we are going to do is you multiply this expression by e power minus 2ka. If you multiply the first term, we will take term by term. If you multiply the first term by e power minus 2ka, this will become 1. And if you multiply this minus 1 with this e power minus 2ka, you will get 1 minus e power minus 2ka. And similarly, if you multiply this with e power minus 2ka, this will become 1. So naturally you will get only the terms inside the bracket, that is m alpha over h cross squared minus 1. Then you multiply the second term also by e power minus 2ka. So now we got this final expression. Then you can further simplify this. You take this minus 2 minus e power minus 2ka to the other side. You join here. Then we have already taken e power minus 2ka outside the bracket. Then this will become just minus will become plus 1. So the first term we are 1 is equal to, now the left hand side is 1, right hand side is the first term we are taking as it is, second term we are bringing this exponential term here, then this will become minus 1 plus 1. You remember that we are bringing e power minus 2ka to the other side in the, because we, here you have exponential term, so you can take exponential term as a common, then this will become plus 1. So this will become minus 1 plus 1. So minus 1 plus 1 is 0. So this can be cancelled each other. Then we will get 1 is equal to 2m alpha over h cross squared k minus 1, and the second term is 2m alpha over h cross squared k e power minus 2 ka. So this is we got, we will reduce it further. Now we got this expression. Here you can notice that there is a minus 1. You bring minus 1 to the other side. So you will get 1 plus 1, 2. 2m alpha over h cross squared k plus 2m alpha over h cross squared k and this exponential term. Now you divide by 2, both right hand side and left hand side. You will get this is 1. 1 is equal to m alpha over h cross squared plus m alpha over h cross squared k e power minus 2k alpha. Now you take this as a common factor here in the right hand side. So 1 will be equal to m alpha over h cross squared k 1 plus e power minus 2ka. And now what I am going to do is you bring to the other side, that is this left hand side. Then you will get inverse of this inverter, that is h cross squared k over m alpha is equal to 1 plus this exponential minus 2ka. Now you bring this 1 to the other side, that is then it can be written as that 1 will become plus 1 will become minus 1. So minus 1, which is equal to this exponential term. That is e power minus 2ka is equal to h cross squared k over m alpha minus 1. Now we will see what will happen further. Now we got this solution. This is a even solution. You know, this is even. Why it is even? We have taken the wave function for x is greater than a, positive x direction, a e power minus kx, and for negative direction it is a e power kx. That is, we have taken f of x is equal to f of minus x. So this is equal to this. Here what we are going to do is, in the problem they asked to find the allowed energy for alpha is equal to h cross squared ma. Here you replace alpha by h cross squared ma. Here you have h cross squared k m alpha. Alpha we are replacing by h cross squared ma. So now this h cross squared will get cancelled with this h cross squared, and this m will get cancelled with this m. So you will simply get ka minus 1. So now you keep 2ka as z. 2ka as z. Then ka will be z minus z divided by 2. So e power minus z is equal to z over 2 minus 1. Now you can plot the graph, because both side, here you can see both side you have k. Even if you take it here, both side you have z. So this is transcendental equation. You can solve only either by numerical method or graphical method. Now we will solve it by using the graphical method. This red color curve is exponential one, and this blue color you can see that is z divided by 2 minus 1 for the first wave function. So now there is one point of intercept, only one intercept here. Now you keep this alpha is equal to h cross squared 4ma. That is this alpha, and you take that, that is h cross squared k over m alpha. Instead of alpha you replace h cross squared 4ma. 4ma. Now you can cancel some of the parameter. First you can cancel this h cross squared, and you can cancel this m. Then you will get 4ak. So 4ak, since we have taken this as z, this will be 2z, because 4ka, z equal to 2ka, naturally 2z will be 4ka. So I am replacing 4ka by 2z minus 1. Now I will get this graph curve, straight line. This is equal to the straight line mx minus 1. Origin is at minus 1. So here I will get one intercept. For the even solution, we got the m value, whatever may be the alpha value, we will get only one solution. In even we have one solution. Definitely, surely we got one solution when alpha is h cross squared over ma, or alpha is equal to h cross squared over 4ma. Now we will see for odd solution. So far, we have seen the even solution, that is f of x is equal to f of minus x, that is even solution. Now we are going to see it for odd solution. Odd solution means f of minus x is equal to minus f of x. Earlier case it is minus f of x is equal to f of x. So in that case we have seen power minus 2ki is equal to h cross squared k over m alpha minus 1. In this case, because f of x is equal to f of minus x is equal to f of minus f of x, that is, you take minus, multiply this right hand side by minus, you will get 1 minus h cross squared k over m alpha. Now you do the same thing. You keep alpha, replace alpha as h cross squared over ma, h cross squared over ma. Here it's given in the problem. So this will become 1 minus ka. So as I have done it for even case, so this will be z. Naturally this will be z divided by 2. So this will become e power minus z is equal to 1 minus z by uh, 2. That is right hand, left hand side exponential term shown in red color. It's a exponential term. Then 1 minus z by 2, the right hand side, it is shown in blue color. There is one intercept. So, when alpha is greater than h cross squared over 2ma, here as shown here. So you have one odd solution we have seen already, and we have seen one even solution already. Now we are seeing odd solution. So there are two bound state. One is for odd and one is for even. Now what will happen if alpha equal to h cross squared over 4ma, that is alpha is less than h cross squared over ma. So that is here if you replace alpha by h cross squared over 4ma, you will get 1 minus 2z, which I have shown in green color. There is no intercept. So in this case only even function you got one state. So here you have one bound state. Subscribe to my channel to get my latest videos, and join my channel to support its growth and enjoy the exclusive perks. Also use the thanks button to make one-time contribution and support my channel. Thank you very much.